Hi AAT, this is section 3.3, dividing polynomials. So in Algebra 1, you learned how to do long division with polynomials, and in Algebra 2, you added on synthetic division, which is a little easier in form, but both of them are really important for different reasons. Long division has some applications that you have to be able to use later. So we've got to make sure we can do it both ways. So rules for dividing polynomials. You need to make sure all your terms are put in descending order. We've already talked about how these exponents need to go down if you're in standard form. And you need to put a 0 times x to hold the place of if you have any missing terms. So if this went to from a fourth to a third, but it skipped a squared, you would need to put in a 0 times x squared, because there's no x squared terms, to hold that place before you start dividing. So just like when you long divide with numbers, we have, oh, my pen's not working, a divisor. So whatever's going in, we put on the outside of our house here. That's our 2x plus 1, and it's going into 2x to the fourth plus x to the third minus 2x squared plus 9x plus 5. All right, so we only look first at the first terms of both polynomials, of your dividend and your divisor. So we look at this 2x and we look at this 2x to the fourth, and ask ourselves, 2x times what is x? 2x to the fourth. Well, I already got the 2, but I need 3 more x's, so I'm going to multiply by x to the third. Very important. Notice these x to the thirds here are going to all line up. All the way down here, we're going to have x to the thirds. All the way here, we're going to have x to the seconds. Make sure all of your exponents are lining up as you go down along the way. Here on our x's. And then at the end, we'll have the constant terms. Okay, so we got x to the third. Now we're going to multiply it by both terms. X to the third times 1 is x to the third. X to the third times 2x is 2x to the fourth. Remember, when you're dividing, you actually subtract this second line. So one way to easily remember that is when you make the line, you're going to change the sign. You're going to change the sign of both things to subtraction to make sure you're subtracting. We're doing the opposite. So 2x to the fourth minus 2x to the fourth is, of course, gone. X to the third minus x to the third is, of course, gone. It doesn't always happen that way. And then we're going to drop down our next term. And since we have 2 terms going in, we're actually going to drop the 9x as well. So then 2x plus a 1. We just look at the first term, 2x, and look at the first term here, negative 2x squared. That's the only one we care about. So 2x times what is 2x squared? We've got to multiply by a negative, and we need an x. So I'm going to put my negative x right here, so it's above all the x's. I had no x squared to put up there, so that's okay. So negative x times 1 is negative x. I'll line it up with all the other x's. Negative x times 2 is negative 2x squared. So those should be the same thing. But when I make the line, I change the sign. They're now addition. So negative 2x squared plus 2x squared subtracts away. That first term should always subtract away. 9x and 1x is 10x. Drop the next term. Now 2x first term will go into 10x first term 5 times. So I'm going to put a 5 up here. 5 times 1 is 5. 5 times 2x is 10x. And again, I'm going to make the line and change the sign. 10x minus 10x is gone. 5 minus 5 is gone. I have no remainder. Now, what do I have left? What is my answer? I have x cubed minus x plus 5. So your answer is going to be written in the term of a polynomial. So the answer is x cubed minus x plus 5. Make sure you have pluses or minuses between everything. The remainder, if the remainder is 0, then the divisor is a factor. Because we know, we know from dividing, like if I'm dividing 2 into 6, let's make it real simple here, I would get 3. And I would know that 3 times 2 is 6. Well, the same way, since I divided this big polynomial by 2x plus 1, I know now that x cubed minus x plus 5 times that 2x plus 1 must equal what I started with, 2x to the 4th plus x to the 3rd minus 2x plus 9x plus 5. 2x plus 1 is a factor, as is x cubed minus x plus 5, because there was no remainder here. Nothing left over. Okay, so let's try it again with this one. So x minus 1 goes on the outside, and we have 2x cubed plus x squared. I'm looking to make sure I'm not skipping any terms. If I skip a term, I need to put a 0 in front of it. So we got an x to the first, and then a 2. So just look at the first terms. X times what is 2x to the 3rd? Well, I need a 2, and I need 2 more x's. So that's going to be an x squared, so I'm going to put it on top of the other x squared. 2x squared times x is 2x to the 3rd. And 2x squared times a negative 1 is negative 2x squared. Make the line, change the sign. This should always go away. X squared and 2x squared are 3x squareds. Take your time, because if you miss one term along the way, it's going to mess everything up. Drop down the next term. X will go into 3x squared. Only look at the first terms. 3x times 3x times x is 3x squared. 3x times 1 is negative 3x. Make the line, change the sign. This should always go away. Negative 4x plus 3x is just x. And I drop down the 2. Look at the first terms. X will go into x one time. So my constant should go on top of all the other constants. 1 times x is x. 1 times negative 1 is negative 1. Make the line, change the sign. This term's gone. 2 and 1 is 3. So this one has a remainder. So when I write the answer, this should be written like a polynomial. So I'm going to put pluses in front of it and between it. 2x squared plus 3x plus 1. And just like if I was dividing, let's say 5 into 13, I would go 2 times, and I'd be left with 3/5. Your remainder, we put over here to make it an improper fraction. A proper fraction, a mixed number. Same way here. We got a remainder of 3 over what we're dividing in, which is x minus 1. So there's the final answer, 2x squared plus 3x plus 1 plus that remainder 3 over x minus 1. So if there's a remainder, always add it to the end as the remainder over the divisor. So remember, this is the divisor, this part is the dividend in the house. All right, moving on. Example 3. So I want you to give this one a try. First, I'm going to look, though. We'll write it out together. This is a 3x to the 5th minus, notice there's no x to the 4th term, so I need to write in a plus 0x to the 4th. So if you're missing a term, make sure you put in a 0 to placehold it, minus 8x cubed plus 2x squared minus x plus 1. So all the rest of the terms are there. So that's the dividend, and we're going to divide it by x plus 2. So if you feel like you can, give it a pause, give it a try, and then come back and check. Okay, the final answer to this one is 3x to the fourth minus 6x cubed plus 4x squared minus 6x plus 11x. And the remainder was negative 21. So we put that negative 21 over the divisor x plus 2. And that's our mixed number as our final answer. Now I really should have had this fourth over the fourth and the third over the third just to keep everything organized, but I kind of ran out of space. But if you made a mistake, look back. Make sure you change the sign when you combine things. Okay, so let's look at synthetic division. Synthetic division is an easier way to do these same problems, but you can't always do synthetic division. You can do synthetic division when you're dividing by a binomial. Once you have a trinomial or something really weird looking, you've got to be familiar with the long division. And there's other things when you're graphing where we're going to have to know long division too. So both ways are important. So you remember this from last year. You're going to take what makes this equal to 0, which is negative 2, and that's going to go on the outside of the synthetic division. Then I'm going to take the coefficients of all of these things, which is 3, negative 8. Oops. Remember, I skipped an x to the fourth, so you got to put in a 0 if there's an x to the fourth, so it's not negative anymore. So a 3, a 0, a 2, a negative 1, and a 1. So there's the fifth, the fourth, the, dang it, I lost the 8. The 8, the 2, the negative 1, and the 1. Now I think I have them all. In fact, that is a mess. I'm going to write it one more time. Negative 2 into 3, 0, 8, 2, negative 1, and 1. The coefficients of all those, and have to have a 0 if you skip something. So now we're going to make a line. First thing you do is drop that first coefficient. You get 3. You do negative 2 times 3, and you get negative 6. This time you don't subtract it, you just combine those. 0 and negative 6, you kind of already changed the sign, so you're already kind of doing the opposite. 0 and negative 6 is negative 6. Then negative 2 times negative 6 is 12. Combine 8 and 12 is 20. Negative 2. Wait a minute. That's negative 6. And that's 12 and negative 8. That was negative 8. Oh my gosh, I can't get this right. Negative 8 and 12 is a positive 4. There we go. Negative 2 and 4 is a negative 8. 2 minus 8 is a negative 6. Negative 2 and negative 6 is a 12. Negative 11 plus 12, negative 1 plus 12 is an 11. Negative 2 times 11 is a negative 22. And 1 minus a 22 is negative 21. Now this last term, whatever it is, sometimes we put a little line there, that is always going to be our remainder. Okay, so these are our coefficients. 3, negative 6, 4, negative 6, 11, and it was an x to the fifth, so now we have what we call depressed the equation. It's gone down a degree from what it was before. We had an x to the fifth, it's going to become an x to the fourth. So this is 3x to the fourth minus 6x to the third plus 4x to the second minus 6x plus 11. And then our remainder, again, we put minus 21 over that divisor x plus 2. So, kind of weird, but you should be familiar with it already. This is the same answer as we got before. All right, so let's try it again. Here, we're just trying to find the degree of the quotient. Is 1 less than the degree of the dividend. So if we start here with an x to the fourth, our final answer is going to be an x to the third. So we're going to synthetically divide. Make sure you use the opposite sign of that binomial when you set it equal to 0. So we have 4 into, and then our coefficients are 1, negative 2. We have no x squared. Be careful of that. So that means we need a 0 in for the x squared, minus 31 for the x, and negative 4. And then we make a line there. Drop the first term, get 1. 4 times 1 is 4. Combine, we get 2. 4 times 2 is 8. Combine, we get 8. 4 times 8, 32. Combine, we get 1. And 4 times 1 is 4. Remember, this is our remainder. We usually put a little line there to let us know our remainder is 0, which means that x minus 4, our divisor, is a factor. This is the factor theorem because the remainder was equal to 0. So we started with the x to the 4th. We're going to knock it down to an x to the 3rd. So 1x to the 3rd. We don't put the 1 there. We know that's just x to the 3rd. Plus 2x squared plus 8x. And then don't forget your constant term, 1. And if we multiply this all times x minus 4, mass distributed, we should end up with what we started with. Okay, B. So we're going to divide by 3 into our coefficients, 3, 2, 1, 0. I don't have to put any zeros. I'm not missing any. So that's a 1, 2, 8, and 1. Not so bad. Drop the first one, 1. 3 times 1 is 3. Well, add 5. 3 times 5 is 15. Add 23. 23 is 69. Add, and our remainder is 70. So knock it down a degree. It was an x to the 3rd. It's now a 1x to the 2nd plus 5x plus 23. And our remainder is 70. Make sure you do plus 70 over divisor x minus 3. So unfortunately, synthetic division only works for divisors in the form x plus a or x minus a. The coefficient of x must be 1. It can't be used with divisors of 2x minus 3 or x squared plus 5. Okay, so there are weird ways you can do it with this, but it's just not worth the time, really. So make sure that you're only using synthetic division when you're dividing something like x plus 2, x minus 7, something like that. Okay, we're going to stop right there, and you have another video coming up.